So today we are going to do a titration problem where we solve for the initial concentration of the acid in this titration. So let's give the problem a read. A 35 milliliter sample of an aqueous solution of HBr of unknown concentration was titrated with an aqueous 0.485 molarity BaOH2 solution, and it took 17.3 milliliters of the base to react to reach the equivalence point of the titration. What is the initial concentration of the acid? So starting off, I am going to convert over these milliliters into liters because molarity is in units of moles per liter. So let's write this HBr, which is a strong acid, and we have 0.035 liters of that sample. And next I am going to write out what we have for the base, which is BaOH2, and that's very important, the 2 here, because there is going to be, because this is a strong base, when it fully dissociates, there is going to be 2 OH minuses that come off of this compound. Okay, so we have, for this strong base here, we have 0.485, and it's in molarity, which is a concentration, but what molarity is moles per liter. And it took 17.3 milliliters of the base to reach the equivalence point of the titration. So I'm going to convert the 17.3 milliliters over into liters. And that is going to look like 0.0173 liters of the base. And what we want to do, because we're mixing a strong acid with a strong base, we know in this titration when it reaches the equivalence point that the moles of the base are going to equal the moles of the acid. So what we want to do is we want to solve for how many moles of the base that we have from the information that we're given. So we have the 0.485 moles per liter. We know how many liters were used to reach the equivalence point, and we know how many, we'll be able to solve for how many moles of the OH that we come out to have. So what we're going to do is we are going to multiply this value, and then we are also going to multiply it by 2, because for every 1 mole of the Ba, there is going to be 2 moles of the OH minus. And what this is going to do is when we multiply this out, it is going to cancel the liters units, and it is going to also cancel out this mole, and what we're going to be left with is the moles of the OH minus that is going to react with the acid. So what this is going to equal out to be is 0.01678 mole of OH minus. And since we have solved for how many moles of OH minus there are, we know, since they're both strong acid and a strong base, that this moles right here is going to be equal to how many moles of the acid there are. So we're going to have 0.01678 mole of the acid, and then we also are given the volume of the acid, and it's asking for what the initial concentration is, which is in molarity. And what molarity is, again, is moles per liter, and we are given the liters here for the acid, 0.35 liters. And when you divide this out, we are going to get 0.479 molarity HBr. And this is going to be the answer here. Hopefully this helped. Thank you so much for viewing. Please leave a comment as to some questions that I can do. I appreciate it. Thanks so much.